Hello there and welcome back. What we're going to do in this video is find the angular speed in revolutions per minute of a bicycle wheel with 24-inch diameter tires that is traveling at 15 miles per hour. So the idea to understand here is that any point on the rim or on the edge of a bicycle tire is traveling 15 miles per 1 hour. So this 15 miles per hour is a linear speed, which remember we call v. Okay, so what we're going to do is use this idea and some unit conversions to convert this to an angular speed in revolutions per minute. So the first thing to understand is the diameter has a 24-inch diameter. The diameter is 24 inches. So that means that the radius is actually 12 inches. Now the linear speed is measured in miles per hour. So that means we need to convert either inches to miles or miles to inches. It's much easier to convert miles to inches because there's a lot of inches in a mile, but the number of miles in an inch is very, very, very small. It's going to be a decimal and very, very difficult to work with. So our linear speed is 15 miles for every hour. And since our target is to have the answer in revolutions per minute, we want inches in the numerator because that's the unit of measure for the radius, and we want minutes in the denominator because that's the unit of measurement of time that we desire. So we have two things to change here. Well, we'll work with the distance first. So 15 miles, we know that every mile has 5,280 feet. So I want to put miles in the denominator to cross out. So every mile has 5,280 feet. And I still have to get to inches. So I know that every foot has 12 inches. So that takes care of the inches portion of it. Now we want to change hours to minutes. So since hours is in the denominator, I want to put hours in the numerator here. And I know that each hour has 60 minutes. So that right there is going to convert our linear velocity or linear speed into inches per minute. So let's see what that is. So we have 15 times 5280 times 12, and that's our numerator, and then we're dividing by 60. So our final answer there is 15,840, and that's inches per minute. Now that, again, remember, is a linear speed. So remember that linear speed, v, is equal to the radius times the angular speed, omega. Now remember, omega is measured in radians per minute. In this case, radians per minute, because our unit of time is minutes. So we actually already know two of the three things here. We know the linear velocity is 15,840. We know the radius is 12. So that means we can find omega. So that means omega is equal to 15,840 divided by 12, which I'm going to do over here to the side. And that is 1,320. Remember units, that's radians per minute. Now to write the answer in revolutions per minute, we have one more conversion to make. So I'm going to write this like so down here. Radians for every 1 minute. Because we have to remember how many revolutions or how many radians are in one revolution. We know that each revolution has 2 pi radians. So that means radians go in the denominator. And that's every revolution. So that means we end up dividing, so that means radians goes away. We end up dividing 1320 by 2 pi to get the number of revolutions per minute. So I'm going to divide that by, in parentheses, 2 pi. And rounded to the nearest whole number is approximately equal to 210 revolutions per minute. which we also write as RPM. Okay, so to the nearest whole number, 210 revolutions per minute. And that is how we solve that problem.